Hi, it's Kevin Lebates here, and in the previous video I made about token vaults, I alluded to the fact that they have something in common with decentralized exchanges or DEXs, and then I made the mistake of mentioning hyperbolic functions, which was wrong because the thing that token vaults and DEXs have in common doesn't have anything to do with the bonded curves or the hyperbolic functions that DEXs use to work out how much of token B you are going to get if you insert token A. Instead, the thing that they have in common is how they deal with people providing more liquidity to them. So when you're looking at a DEX, if you understand how the underlying bonded curve changes when somebody deposits more of token A and token B to provide liquidity for the DEX, then you'll get some kind of sense of what's going on in token vaults when people deposit funds in the token vault and get shares in return. And I've been thinking a bit about how I can explain this, and the best way I've come up with is to look at a much simpler contract, namely something like wrapped ether. And if you've looked at my video on wrapped tokens, I'll put a link in the comments or in the description of this video. Wrapped ether works very plain and simply, which is if you deposit X amount of ether, you get back X amount of wrapped ether. And wrapped ether is an ERC20 token. So there's no question about what is going on with regard to the other people who are depositing ether and getting wrapped ether, or who are depositing wrapped ether and getting ether back. They're all kind of independent. There's not really any sensible accounting going on other than keeping track of how much of the asset you've deposited and how much of the wrapped asset you get back. It's all fairly simple stuff. In a token vault, it gets a bit harder because when people deposit an asset into a token vault, they get shares back, but then the token vault may start to turn a profit, and they should have a claim on some of those profits, but people who come along later and deposit assets because they think the token vault is doing well should not be getting part of those earlier profits that were made before they contributed to the vault. They should only get a share of the profits that are returned after they've invested. And the way that a token vault does this is that initially, before any profits have been made, if you deposit the underlying asset, you get an equivalent amount of shares back. But if the token vault starts to make a profit and other people come and deposit assets, they actually get less shares than the original contributors did. And it's this formula that calculates how many shares you get for the underlying asset, and the way that the cost of those shares changes over time that acts as the accounting system for the token vault. So take an empty vault. Let's say I deposit 1,000 tether into it, and then I get 1,000 shares back, and then the vault makes a profit of 100 tether. So now there's 1,100 tether in there. I would have a claim to all of that tether because I'm the only investor. If somebody else now comes along and also deposits 1,000 tether, they're not going to get 1,000 shares. They're going to get slightly less than 1,000 shares because they're not supposed to have a claim on that initial 100 tether profit. And then if the vault goes and makes more profit, they will start to get a claim to part of that, those gains. And it's the calculation of how many shares you get for depositing the underlying asset that allows a token vault to fairly and equitably distribute the profits and allows you to claim back your original stake. And if it's all been implemented correctly, you should always be able to get back your original stake, provided the vault hasn't made a loss, and you'll get a share of the profits that is due to you. So when you look at a DEX, kind of the same thing happens there if you're a liquidity provider, if you're putting in a token pair of token A and token B that the DEX allows you to exchange. And so that's really where I was drawing the comparison when I was walking along thinking about token vaults. It reminded me of that aspect of how DEXs work too. And it's a very clever accounting trick to keep track of a large number of changing variables over time without having to loop across all the different events that have happened it almost magically does the accounting for you. And in that sense, I think it's very clever of the people who came up with things like DEXs and token vaults to have worked out such an efficient way to keep track of who owns what. Now, there are problems with the token vault system, and they're related to the thing called slippage that you also see in DEXs. And that is when somebody adds an awful lot of extra assets to the token vault or withdraws a lot of them, you can end up in a situation where they can manage to get hold of more of the asset than they're allowed to. This is partially due to rounding errors, and well, actually it's pretty much all due to rounding errors, and there are tricks for getting around it, but those will be the topic of a video in the future. I hope you've enjoyed this one, and I'll see you in the next one soon. Bye for now.